Okay, welcome this afternoon. My name is Cortland Starrett, and my presentation is on embedded modeling in Eclipse. So hopefully you're in the right room for that. A brief introduction of myself, and then I'll introduce my co-presenter who's virtual today. I am a EE and computer engineering graduate from Purdue University in 1988. And so I have been working in embedded control and modeling for a number of years. I started my career in embedded systems. Where I have worked is where the software and the hardware interface come together. I worked at IBM on disk drive controllers. In the early part of my career, I've built equipment for chemistry labs for a medical supplies company. And I've worked on the real-time embedded control for letter mail sorting equipment, sorting 10 letters a second, OCR images, and delivering letters into pockets that then get sorted again as the mail moves around North America, Australia. Deutsche Post was one of our users. But then I've also been in recent years involved in modeling tools, and specifically a tool called Bridgepoint, and more recently Papyrus and some Papyrus variants. But I have been modeling either object-oriented analysis or Schleyer-Miller xtUML since 1991. My co-presenter is Charles Rivet, and he was going to be here, and we're going to have this battle. Well, we're going to try to have this battle virtually, but Charles has also been modeling for many years. Instead of Schleyer-Miller, the methodology that he has been using through the years is called ROOM, Real-Time Object-Oriented Modeling by Bran Selleck, and which is the modern flavor of that is called UML RT. Now, what's has been true about our two careers is that up until recently, our careers have been parallel, but in competition and bumping heads. Charles has been espousing one methodology. I and the Schleyer-Miller camp have been espousing another methodology, and we were in corporate, commercial, proprietary tool vendor situations, and so we actually were against each other. So not only would we say good things about our own stuff, we would say bad things about the other guy's stuff. And so you'll see that we're going to use that history a little bit in the opening part of the presentation. And because now both tools, both methodologies live within the open source software world. So nobody owns the code, nobody owns the tools. The tools are then supported by the community and by commercial support companies, but there's no commercial licensing. You can get Papyrus for xtUML. You can get Papyrus for UML RT. You just download them, you run them. There's ways to learn about them. So if we have time, this presentation will start with a drama where Charles Rivet will join us virtually, and we'll have a battle. And then I'll get into a little bit more of the technical differences between the two methodologies and the two tools that support them. Questions or comments before we start? Okay, feel free to interrupt me anywhere along the way. I believe that I'll be able to get through the material, and we'll have questions at the end also.
Hi, I'm a UML RT.
And I am an xtUML.
UML RT is a domain-specific language based on UML to simplify modeling of complex embedded systems, so all other approaches suck.
xtUML is based on the Schleyer-Miller method, which is executable and translatable. So really, it's Charles' tool that is for sissies.
Well, my tool lets you use capsules to represent the system's hierarchy and protocols to describe how messages are exchanged. So this tool is the best, and the other one is lame.
Lame? xtUML has Bridgepoint to support it, and it focuses on class modeling first with a data, control, and processing order to the methodology. And so it's definitely the other methodologies that are lame or for sissies.
Wait, my capsules look like your components.
And my word, my interfaces look like your protocols. We're doing the same thing. UML RT and xtUML are trying to accomplish the same things. I wonder what else we have in common. We face the same challenges. Both methodologies are approaching the deeply embedded world, where time criticality is a big challenge, focusing on distributed processing in resource-constrained environments that are high complexity.
Yes, and the goals are also common, namely abstraction, productivity, and of course successful projects.
And as of the last 2 years, we're doing the same things separately but together. We're together in the Eclipse world, we're together in the Papyrus Industry Consortium, and both sets of tools are now open source and freely available.
Can you agree that C plus VI?
Emacs.
Yes, okay. Can you agree that C plus VI, or Emacs, is the right language and tool choice for some particular tasks?
I could see where C and VI or C plus Emacs is exactly the right tool, especially if you were writing a driver for the Linux operating system or communicating low level with a printer. So here is an example where the tool choice is driven by the application and the requirements of what you're trying to get accomplished. It's not a one-size-fits-every situation. So the question is, how do we choose?
So how do we help people pick an approach?
The first recommendation when choosing between a particular methodology is, first of all, congratulations if you're using a methodology. The alternate to a methodology is ad hoc and not as scientifically guided. So first, choose a methodology, and the first step there is most methodologies are well documented. UML RT and xtUML have books written about them, and you wouldn't have to read the whole book, but if you would read the first 3 chapters of both of these books, it would take a couple of hours with each book, and you'd have a good picture of what the strengths and weaknesses of each of the methodologies is.
In some situations, there will be a deciding factor like the need for interpretive execution or the existence of a large library of existing dialect models.
Yeah, so what Charles said is that if you're in a company or a project that already has one methodology or a bunch of models that exist in that methodology, that can play into deciding which methodology to use. In a moment, we'll spend a little bit of time looking at the technical differences. There are technical differences, there are strengths, there are weaknesses, and the choice of methodology and tooling can be driven by the requirements of your environment, not by just random rumor or hearsay.
And please, do not be afraid to ask us questions.
So this looks like it could become a beautiful friendship.
So we might as well recognize our differences and similarities and work together to make MBE and Papyrus successful.
Thank you, Charles. Let's dig in just a little bit more technically now and look at the two methodologies. So, assuming the 2016 state of the art, we'll briefly review methodology, notation, workflow tool architecture, and then convergence possibilities for these two methodologies, tools, and notations. So UML RT is based on a methodology that was published at roughly the same time as xtUML. Bran Selleck published the Room book that we saw a picture of there in the mid-90s. Sally Schleyer and Stephen Meller published their seminal works on object-oriented analysis and recursive design in the early 90s, based on work that both of them had done in the 80s. The methodologies have the same goals, but the approach, they take different approaches. UML RT is elaborative. It's a continual top-down refinement, functional decomposition, whereas xtUML is translative. You build the models, and instead of adding more details to the models, you'll use a model compiler that translates the models from their modeled form into their implementation form. And instead of being functional decomposition, there's a focus on domains, which is separating by subject matter rather than just breaking down the complexity. UML RT is object-oriented in that it focuses on encapsulation, where the similar idea in Schleyer-Meller is a relational model of the data. Schleyer-Meller is known for starting with data modeling, class diagrams, focusing on the abstractions and the relations between them. Both methodologies are executable. Both methodologies emphasize that the way that you know something works is you run it. And so pictures are nice for documentation, but for a system that you want to specify and specify correctly and know that the specification is correct, you've got to execute it. And so the single biggest commonality between these two is that these aren't just pictures. Both of these methodologies build models that you run the model. UML RT is an abstract modeling language in that there is a focus on, to a certain extent, modeling in the language and vocabulary of the problem rather than the language and domain of the target implementation. And Schleyer-Meller is even more so. In UML RT, there's a runtime. And so architecture being factored out has been recognized. There's a big focus on architecture. And in Schleyer-Meller, likewise, architecture is factored out, or what we call architecture is factored out into a domain called the model compiler. The runtime in UML RT comes with the methodology and comes with the particular tool sets. Runtimes, basically there's a recipe for the runtime that is supplied in Schleyer-Meller, and it's up to the architecture domain, the model compilers, to instantiate that runtime. So the methodologies have the same goals, but there's differences in the approach that is taken. Now the notation. If you looked at a UML RT model and you looked at an xtUML model, you'd see quite a bit different. You'd see some similarities that we showed in the drama, where a component in xtUML looks like a capsule in UML RT. But when you get below that level, things start to get quite a bit different. Where in UML RT you'll have a protocol, in xtUML you'll have an interface. Data is modeled with class diagrams in Schleyer-Miller, xtUML, and in UML RT, data is modeled as C++ classes. There's relations between the classes and a broad variety of interrelating the classes in that class model. Again, Schleyer-Miller focuses on the class modeling part of it. Both have state machines. The UML RT supports full hierarchical state machines, roughly the Harel state chart. And Schleyer-Miller has only flat state machines and will have multiple communicating state machines, whereas complexity is managed in the UML RT by layering the state machine. The action language, the processing part of the notation in Schleyer-Miller is actually it's an action language, and in UML RT it's C++. At least in the currently supported tools, the language could also be Java in a Java version of a UML RT tool, but the distinction is that you will use your target language as the action language in a UML RT model. The order that you do things is a little bit different. In UML RT, it is distinctly functional decomposition and progressive refinement. So you start with a top capsule and you decompose. You focus a lot on the messages passing between the functional elements in your model. Protocols, strict definition of not just the data that is carried by these messages, but the sequencing of the messages. One of the most powerful parts of UML RT is establishing a capsule and the inputs and outputs in more than a list of messages, but additional specification in the ordering and legal sequencing of those messages. In the Schleyer-Miller method, you start with this domain separation approach where you identify subject matters like user interfaces, the application level, service levels like network communication or signaling are divided up into domains, which then each domain is modeled in classes and states and activities in that order. Finally, both are deployed. The Schleyer-Miller defines a component diagram that packages the classes, states, and activities into something similar to a capsule, but defines deployment. And then the system is generated. The workflow in UML RT is that the code will be generated for the structural aspects of the models and then compiled onto the runtime environment. Now just a look at one instance of each of these tools. UML RT is available from the Eclipse community, downloadable as Papyrus RT. It's, I think, version 0.8 as of Monday. And so it's an Eclipse project in incubation, but a fully executable, fully usable version of the tool can be downloaded, and its architecture is based on Eclipse with EMF as the data layer and GMF as the graphics layer, packaged under the Papyrus platform. There's a UML RT meta model that sits side by side with the UML2 meta model. Most of UML RT is persisted as UML2. Some of the extensions are extended into the UML RT meta model for translation purposes. and the application writing on top. The xtUML architecture starts with Eclipse, but then has an older set of technologies with a Java and SQL persistence layer with GEF as the graphics layer, and the UML2 meta model is not present, just the xtUML, which supports the UML2 diagrams but does not persist them in the standard UML2 format with the app writing on top. xtUML is actually in the process with Papyrus. I should say that Papyrus xtUML Bridgepoint is also downloadable in its current form for free. Papyrus xtUML Bridgepoint is actually migrating to an architecture that sits on atop the Papyrus platform and is just trying to solve the very tricky steps that are needed to take it from where it is today to where we want it to be on top of Papyrus without breaking anything. There's some possibilities for convergence. So this presentation is really kind of an early version of a presentation that will ultimately help with providing further guidance to engineers in choosing a methodology and choosing a tool set. But along the way there's been questions about, well, you know, what can be common between Papyrus RT and Papyrus for xtUML? Should we merge the methodologies? Combine the notations into one giant notation, integrate the workflows into a single tool? Should there be a common tool architecture? And again, the first slide in this part of the presentation said, assuming 2016 state of the art, there's some things that for the immediate future we're ready for, and some things that longer term may take some more discussion. And so the way things are headed at the moment, is that a common tool architecture is the first step, even though it was the last in the list. The previous slide showing the migration onto Papyrus can allow the methodologies to have their distinctives, can allow the notations to, let's not combine the notations yet until there's further study. It may be confusing because there's some things in the xtUML that have one name and it has a different name in UML RT. And the workflows, they're different. As things mature, there's possibilities of combining workflows and tools. But let's start with a single architecture and allow the two dialects to coexist, but have, as a Eclipse and Papyrus community, strive for something like 80 to 90% common code, because we're based on Eclipse, EMF, Papyrus, and have commonality underneath, and just allow for the distinctives in the methodologies at the high-level application layer. And so that helps drive the roadmap for the next year or so. That's what I have to this point. Questions or comments on either the drama portion or the technical part?
Well, a question about the technical part. When it comes to executable models, are you referring to code generation for the target platform, or is it more about the models at runtime? You have some interpreter at runtime, which basically reads the models at runtime and interprets it.
There was a presentation at the Models Conference that was in Saint-Malo, France, about 3 weeks ago, and it talked about levels of executability. And being able to execute at the code generation at the compiled level is the level of execution that is shared between UML RT and xtUML. There's another level called translated, where because of the action language, because of the abstract action language in the xtUML, the processing part of the model can be translated into C or Java or even hardware languages, but can also be interpreted. So it's a really good question when someone says executable UML or executable model. You need to ask, what are the steps? What sort of execution are you talking about? Can I generate code for it and then run the generated code, or is there a virtual machine interpreter that will just interpret the model? And in the case of the xtUML, there is an interpretive execution engine. It's slow, but it's intended for unit tests. And in the UML RT world, you generate the code and you can run that and debug that on your platform and then again on your target. But you do have to do that compile step.
Really depends on the aspects that you're modeling as well. And we often, I think that what you're referring to is essentially when you have to generate code. But there are cases like people in business process modeling and stuff like that who don't actually generate code. So then in this case, it's clear the need to have true model executability in the context of cases where you have to generate code. Then it's definitely use cases. I think both are valid and both have power.
And driven by the requirements of your environment. I'm mostly familiar with the Schleyer-Miller xtUML world, and some users value that interpretive execution a lot, and some don't even do it. Some stay in that code generation world, perhaps because they've got an environment where they can debug very easily, whereas other environments, that interpretive execution is going to remove bugs, more bugs before going to the generated code, which of course, as soon as you introduce your target, it has the potential of introducing additional race condition runtime.
Also implies that you want to do true model execution. Also implies or assumes that you have some type of action language.
You have to have an action language.
And in other cases where people know that they're going to C++, and Ericsson was facing it, where at some point the choice was to say, it could be revisited, but at the time the choice was taken is to say, we're going to C++ anyway, let's bite the bullet and deal with it. And if we're going to write C++ and we have execution on target and on host, then maybe there's no point having model executability. But again, that was one specific case. I'm by no means against model executability, because I think there are very good cases for that. But I think it's different decisions based on different contexts. I truly believe in model executability personally.
I have a question. I think the strength of the tool are that it supports methodology. You have a methodology that tool will support. So you give you good guidelines and so on. But I wonder about other parts that you have implemented in the tools that you're comparing now. It's more like how you model. The other part is when you have done the model and you want to verify it and want to debug it, you want to execute it. What's the big differences between these two setups?
Okay, yeah, that is not included in the presentation, but I know that at Solid, I think of Anders Ericsson is doing work. There's all sorts of static analysis of models. There's test generation aspects, validation and static validation and verification, as well as runtime validation and verification, and there's differences between the tools there that are not addressed in this presentation.
So another question, what do you think is the, because now you're different states and you have a roadmap for implementing so that you were aligned in a certain level, but what will be the big challenges for you think with going to a new kind of architecture platform with the errors that you have?
There's some big challenges are persistence, the way the models are persisted. Another big challenge is maintaining the simple meta model, but having it be compatible with the UML2, which is not simple. And that's just to name a couple of challenges. Okay, one more question. Okay, I really appreciate the interaction. I'm going to stay around. This guy looks like he's about ready to head out. He's the chair of the Papyrus Industry Consortium, and so he knows about both of these. If you have a question for him, you'll have to hunt him down. But I really appreciate your attention. Thank you very much. Don't forget to go to the, as you've heard on all the presentations, go to the EclipseCon website and rate +1, 0, or -1 for this prezo. Thank you.